Welcome to this new video. We're gonna keep talking about sequences in this video again. So one of the keys to finding limits of sequences is to know some basic ones. So given some basic sequences, we need to find their limits and keep them in our minds when we are dealing with limits. For instance, 1 over n. This is a sequence that has the limit of as we get closer to plus infinity. So what do you think the limit is? So sometimes our logic and our common sense help us find the limit. So think of this one as maybe a loaf of bread that you divide among billions of people. How much they get? They get zero. They got nothing. They are almost zero. So we say zero. Okay. Another limit that we would like to do is 1 over n squared. So this is almost like this one. So you divide something by a bigger number, 1, maybe a loaf of bread, by a number that's very huge. So you get 0. And we can prove that the limit of 1 over n to the power p, okay, with p an integer, is that positive integer, is that this limit is 0. So you can think of it as something that's fixed. We divide it by a huge number. Okay? Think of 1 as being divided by 10 to the power 9999999. So what do you think? What's the limit? What do you get? 0. Okay? Almost. You don't get 0 exactly, but it's 0. So something like 0.0001 or 0.9, it's considered to be 0. Okay? Okay, these are the limits that we need to keep in mind. Another one that we need to keep in mind is the limit of n as n goes to infinity. Okay, so as we keep increasing this number, what do you think it's going to be? It's going to be very huge. That's what we say. The limit of n as n goes to infinity is plus infinity. The same thing for n to the power p when we consider p as a positive integer, so it's plus infinity. Another one is square root of n, and is being positive, so it's plus infinity. Okay. Another thing that we need to keep in mind is the cosine of n is always between -1 and 1. Okay, when n is an integer. Okay, so we need to use this one to find limits. For instance, let's define the sequence by u sub n is cosine n over n. So if we try to find the limit of this sequence, we would use this fact. Okay, in fact, let's do it. Let's use it. So cosine is between -1 and 1, and we divide everything by n. Okay, now we have our sequence. U sub n is between -1 over n and 1 over n. So now the limits. Okay, so this sequence is trapped between these two numbers. We consider them as sequences. Okay, so as n gets bigger, what's this one? So we have seen it. So this goes to 0. This one goes to 0, and therefore the limit of un is 0. Okay, so this is the squeeze theorem for sequences. Sometimes we have to use other things, like let's say n over 1 plus n squared. What's the limit of this one? Okay. Okay, so we can use some intuitive idea to do it. But let's divide everything by n. So here we have n over, we factor here by n, we get n 1 over n plus n, okay? And we cancel by n since n is a positive number to get 1 over n plus 1 over n. Okay, so now what's the limit here? Okay, so the limit here is 0 and this is infinity, but 1 over infinity is 0. Okay, you divide a number by big one, okay, by a huge number to get 0. So the limit in this case is 0. We're gonna deal with this operation later when we have plus infinity is plus infinity, or sometimes we have some finite number, let's say 3 times plus infinity is plus infinity. And we will see that sometimes when we have some forms like 0 over 0 or maybe plus infinity over plus infinity, we can determine the limit. Okay? But for now, our focus is just remember these results here, okay? And keep in mind that we will use them later when we will do more problems.